Hello again. I'm here to tell you about Chapter 15 from our online textbook, and this is all about nuclear chemistry. So let's take a dive in there, see what's going on. This is all about nuclear chemistry, and so you're going to look at the opening essay, and you'll learn about the major types of radioactivity in this section. So this is more of a conceptual chapter, and you won't have much math. A little bit easier. So you'll learn about different radioactivity like alpha, beta, and gamma particles and what the decay looks like. So in this, we're talking about elements actually changing from one type of element into another. So that's radioactivity. It's different than chemical reactions. You'll learn about beta, gamma, and this chart's important. So take a look at that. And so when elements spontaneously divide, it's called fission. And elements can actually fuse together, and that's called fusion. We will do math on half-life, so take a look at this math section in the book. It's not too bad, so don't worry about it. Half-life is how long half of the mass of a particular element changes. So going from 100 grams, half of it to 50 grams, and how long does that take? So this is the half-life time, and it changed from 100 grams to 50 grams. It changed into half of it changed into a new element. So that's what, we don't lose it, it just changes it into a different element. And here's some different half-life years. So like carbon-14 takes 5,000 years, and we use that a lot to do carbon dating, to find out how old something is, how long it's been around on the Earth. And here's some, if you're going into medical careers, radioactivity is important for all the cancer therapies and other therapies and other imaging techniques that we use, so take a look at that. We have units of radioactivity, how much you're exposed to. That's the becquerel, or the Curie, after Marie Curie and her husband. So take a look at that. We won't do too much with this map here, and I'll show you easy ways to figure out half-life and how much you have left. There's also a radioactivity unit called a rad, and different things that you can be exposed to that will give you radioactivity. There's ways to detect radioactivity. And how we use isotopes. So this is important, especially if you're going into medical, or you might want to do something with radioactivity, nuclear power, things like that. And this is the dating I was talking about, finding out how old something is. And you can also use irradiation for food to sterilize it so it doesn't decay. So like I said, this is more of a conceptual chapter, so that's good. And we're going to talk about using nuclear energy in fission and fusion. The important thing here is to be able to, let me see if I can find some, doing nuclear reaction formulas like this, so reactions like this. So we'll do some of that in our class. So here's the end of chapter, and it has some math involved in it for half-lives and things like that. But I think you guys will be fine on this chapter, and one more chapter to go. So good luck, and you guys are doing great. It's good to talk to you, and I'll talk to you soon. Bye-bye.